Hello, my name is Thomas Hanaho, and this is my recording for my assignment for my module called Mathematics 2 for my course Games Development in Year 2. So for this assignment we were supposed to answer questions that were handed out, explain how we got our answers for our questions, and show our questions in Excel. So if we look over here, I have the question written out. An object that moves in a straight line and at a constant speed from the point 2 minus 4 when t is equal to 0 to the point 12:24 5 seconds later. So I was supposed to work this out, put in an appropriate formula into Excel and show the output of it in a graph. So as you can see here is my x values, my y values, and my time values, and this is my graph showing the result. So this is my workings here. This is how I got all of the information that I needed to get these x and y and t values. So I'll go through that now. So I started off with my 2 points, 2, -4, and 12:24. Using these 2 points, I could find the equation of the line using the equation of the line formula, y is equal to mx plus c. But before I could do this, I needed to find m, which is the slope of the line. I did this using the slope formula, which is y2 minus y1 all divided by x2 minus x1. This is where y2, y1, x2 and x1 are the values in the points. So using that formula I got the answer 2.8 here. Using the slope I was able to figure out I can now put this into the straight line formula using the point 2 minus 4. So using this point, I said I'd let x equal to 2 and y equal to -4, and then using this I was able to find c. Now that I have all the relevant information, I can find the actual line. So let x equal to 2, let c equal to -6.8, and m equal to 2.8, and my answer is y is equal to 2.8x minus 6.8, or the point is x 2.8x minus 6.8. So using this I was able to then find the formula to track the distance over time. The formula for this is x is equal to, to find the x in this formula we use the equation x equal to speed multiplied by time plus the initial starting value of x, and in this case the initial starting value of x was 2. You can see up here, and it starts in this graph here, it starts roughly at there. So the next thing we have to do is find speed. Now speed, we can find speed by calculating this using the seconds and the distance. So using this we can find x moves from 2 to 12 in 5 seconds. Therefore speed is equal to 12 minus 2 divided by 5 equals, which then equates to 2 seconds per unit. So for every 2 seconds here on the graph, the line travels this amount of distance. So using this we find that x is equal to 2 multiplied by 2, or 2 multiplied by t plus x at position x1, which is equates to x is equal to 2t plus 2. So therefore the formula that we can use to find the equation for this line here, if we sub it into this set here, is 2t plus 2 is x, and y is equal to 2.8x, which is 2t.2 minus 6.8, minus 6.8. So once I had figured the formula out, I put it into the Excel document. So first off, I had my x value, my y value, and my t value. These values here for t were just randomly selected. I decided to use from 0 to 12. I could have used from 0 to 50 or from 0 to any amount of number that I wanted. So to find x, what I did was I just equals that and put in the formula for t. So as you can see, the formula to find x is 2t plus 2. So that's 2 multiplied by t, which is in this case is this box here, plus 2. And that will give me the answer 2. So I did this for the rest of these selections here, and then I did the same thing for y, except y is a different formula. It is 2.8 by x minus 6.8. So that's what I did. I did 2.8 multiplied by a4, which is the x value here, minus 6.8, and I got minus 1.2. Then I dragged those down, got the rest of the values, and then I printed off this graph here, and this is the graph, the result of the graph. As you can see here, at time 0, the time 0, I think it is. Yes, at t is equal to 0. At time 0, the object starts off at this point here, and then 5 seconds later it travels to this point here, which is 12:24, and in this direction. And this is how we can find the direction that the object traveled. Thank you. Now, that has been my assignment. Thank you very much.